All right, welcome back. This is the next installment on the cam for the vise base. In the previous video, we set up the uh, first setup to rough and machine away the material for the top of the vise. We've got all that programmed in here. Now I'm going to show you how we are going to set up and machine the second and third setup in this video. So we have most of our material now roughed away, most of what we needed. So we're done with this setup. We can click this arrow right here to close that tab because we aren't going to need that anytime soon. We are going to have to create a new setup because our first setup, where we established our X, Y, Z planes, obviously isn't going to work because we're going to have to take this part out of the vise, flip it over, and put it back in. So what we're going to do is a second setup. So we are going to select setup. Here's our drop down. Now for our second setup, we're going to be flipping this over. So I'm going to grab my model, rotate it till it's sitting up, and go through pretty much the same steps we did in the last setup, where I'm going to now select my Z and X axes. So Z, I'm going to select this face. That brings our Z plane up. And for our x-axis, I'm going to select this face. So our x is to the right, our y is now pointing to the back of our machine, and our z is up. Now we have started machining on faces now. So instead of setting up a whole stock box again, what we're going to do is, in this drop down, from preceding setup, which means it's going to go to the setup previous to it, which was our setup 1, and choose the stock based off of what we did in our last setup. Now, that's not all I want to do. I also want to click Continue Rest Machining. By clicking this tab, it is going to automatically figure out what was done in the last setup, and so it will, instead of having another solid block, it will show what we cut around in the previous setup. This is great for reducing airtime cutting, which is exactly what we want. So now that I have that, so in the stock from previous and continue rest, I have my Y, Z, and X axis pointed in the correct orientation. The last thing I want to do is select my 0, 0, 0 point for my stock or my origin, because I don't want my G54 offset now stuck at the top of this block, because the stock, rough stock is never accurate. So I don't know that the top of the stock is now exactly where it needs to be. So I am always going to reference a already machined surface. And I know that the tops of these two peaks now are fully machined. So what I'm going to do is do model box point. So it's going to take a box point off the model. And I know that this point right here, which is going to be nice and easy for me to get to, is fully machined, because that face, this face, and this face have been machined. So I can touch off on this corner for my G54 offset and get an exact number from the base of this model to the top of this model, because I don't know what the exact number will be from the base of this model to the top of this stock, because that stock is still rough. So I always want to reference machined surfaces. If I have any stock that has been machined on previously, always reference a machined surface. Oh, I'm going to now hit OK to accept that, and it's going to populate showing me what my part looks like, also what the remaining stock looks like. So it's got a little top hat still on there, and so now I'm going to start with a roughing cut, because I'm pretty much always going to start with adaptive clearing to get that material removed. Now it auto defaulted to the tool that I've been using, which is the 1/2 inch flat. But I'm not going to use that anymore because I want to show you all how to import entire tool libraries. So I'm going to go into Select. Now, previously in the last video, there was nothing in the vise space setups because I wasn't using a tool yet. Now it shows me tool number 5. This is also something that I am going to change later in the program because I don't want this to be tool number 5. What I am going to do now is show you how to import entire tool libraries. So it is actually very simple. So I'm just going to hit the vendor drop down tab and look for it by alphabetical order. I have Albrecht, Amana, Bits, Bloom, all these different tooling companies. Haas Tooling is right here. So I have already downloaded the Haas Tooling library, but I do not have the Haas Holders library. So that one is not in my inventory yet. But I already have that Haas, so we are not going to use that. What I am going to do is select something that I do use that I haven't downloaded already. Let's see, OSG NMills. So here is the OSG, the OSG NMill library. So from here, I can now select any kind of tool I need. So let's go with a flat end mill, and I am going to do a diameter of 0.5. And so here are our end mills, half-inch diameter, that would be applicable. So right here is the 8200 end mill. Actually, I don't have one of these in inventory. Let's see, which one have I been using? Obviously, I should have this in my hand right now, so it's easier to find. But you can select from the drop-down right here. And in that drop-down, you can select whatever you want, and it auto-imports. So it's pretty simple to use the programmed tool lists from all the different vendors. If the vendor is in there, it is pretty cool and pretty simple. There is ways to find external vendors that are not in this library by going through, and there is it's a lot more involved of a process, but some companies have entire lists of code that you just copy and paste the code into your Fusion folder library. It's a little more complicated, but you can bring in external codes that way. So with that being said, I am going to go back to the vendor tooling Haas vendor tooling library and use their pre-programmed information, because as the job I used primarily, we buy Haas end mills. Not because they're any better than others, but because they are a good, affordable cost versus benefit end mill. So, with that being said, when I select one of these end mills, so this one right here, I have a bunch of these on hand. I'm going to select the 030073, which is the product ID. I know I have that on hand. And in the drop-down right here, it's going to have a bunch of cutting data. And the cutting data is, we already established that this is A36, which is a P0 or 1018 P18 P0 cutting steel. So I am going to go P0 side milling. There is also, if you page down, P0 slot milling. We are side milling, so we're going to select this, select, and it auto-populates with the geometry of the end mill, also with the surface speed, feed per tooth, all of that information already populated in for us. Super convenient, and I highly recommend using that. I will say one thing I have found about using these drop-downs from all the vendors is they have programmed it with a perfect environment in mind. So that does mean that sometimes things go wrong and these feeds and speeds seem kind of fast or kind of aggressive. So sometimes I will manually change my feed per tooth or my surface speed to bring it a little bit lower, because you don't know if even something like a hot saw was used and the edge of your material got hardened, and it might ruin your end mill. So it's always good to keep that in mind, that you can either change it in the programming here or use the override codes on your mill to speed up or slow down the process. Again, this is adaptive clearing, so I'm not going to change most of this information except how far down I want my end mill to go. So I'm going to put this into the vise. I know, again, I'm going to probably put ½ inch in last time because I wanted to be able to reach as much as I could. For this, all of this is finished, so I'm probably going to drop it down to 3/4 into the vise. So 0.80. The reason I'm using 80 and not 750, which is 3/4, is because I want that 50 thousandths of extra clearance. Because if I program it straight to 3/4 and it does come down to 3/4, it might shave a little bit off the top of my vise, and I don't want that to happen. So I'm going to go into my passes tab. Again, one of the things I do like to change is the optimal load. It always sets it to half the diameter, which Haas says their engineers and programmers say that that is good. I have found that in the VF2 I run, which is a good solid machine, but not as rigid as some of the higher end machines up there. Sometimes that can be a little aggressive, so I do like to bring it down to 1/3 of the diameter. And everything else looks good, so I'm just going to hit OK and let it generate my tool paths. So there we go. We have it removing most of the material from the center. So since the adaptive toolpath always does side milling instead of slot milling, we can see that it is doing this swerve pattern back and forth so that it maintains a side milling profile, which is better for the machine and the end mill, but it has left this kind of gap through the center. Now I could just have the end mill slot mill that all the way down, but it does like side milling better, so I am going to continue with an adaptive profile for that. So the next thing I'm going to do is, again, do adaptive clearing, but I'm going to select a smaller diameter end mill. So I'm going to use a different end mill. For this one, I will go with another flat end mill, only I'm going to change my diameter. Haas Tooling Library. My diameter will be 0.7375, 3/8 of an inch. That will give me end mill that can reach down far enough and have rigid enough shank that I will be able to still cut that groove side milling without too much chatter. So if I look through the end mills here, they have the different names. So this one is an aluminum only end mill, and we can see here that it's all non-ferrous materials. So this right here, the HPEM, is kind of their general workhorse end mill. That is what I will be using. Again, P0 because of the type of steel we're using. Select. This is another adaptive program. It's got all my information auto-populated. The one thing I am going to change, though, is my heights of cutting, because I only need this groove cut now. I don't need the end mill doing a bunch of other weird stuff. So what I am going to do is take the bottom cut height from a selection, select there so it won't go past that flat, and I'm going to do my cut height stop from another selection, which is going to be this flat right here. So the cutting window where I'm allowing it to do all its work is now only between those two faces. Optimal load, so again I want to do, instead of 1/2, I want to take that down to 1/3. So 1/3 of 3/8 is 1/8. If I'm doing the math in my head correct. No, makes sense. So 1/8. Everything else looks good. Just hit OK. And there we go. This is going to give us that same side milling pattern. It is going to take us, well, I would say a little bit longer, but this is actually going to still go pretty quick. If we're curious on how long a cut is going to take, we can see that information right here in the lower right corner. So for the adaptive 3 cut, which is this 1/8 end mill, it says it's going to take about 1 minute. That is because it is running quite fast for the speed and the feed. Again, I can check all that by simulating it. It is going to, since I have the setup selected, it'll simulate everything for me. Side milling, facing, and that's the 3/8 end mill kind of doing its thing. So I do know from experience that running an end mill through a slot like this is going to want to kind of gum up, and those end mills, the end mill shavings, are going to want to pack in there. So while it is doing that, I am going to be blasting it with coolant. Fortunately, this is a through groove, so I'm not going to have to worry about things getting packed up too bad, because that coolant blasting through there will push those chips up and out of the way. If too many chips do compact inside of a specific area like that, it will cause breakage of the tool. And so I want to avoid that kind of, well, recutting of chips, not only because it wears out the tool faster, it also can cause breaking, and it also just sounds terrible. It makes my teeth grit every time I hear a machine cut over its own chips. All right, so now we are going to start our finishing applications. So for finishing, I am going to do what I did last time, where I'm going to use a series of traces. So the first thing I'm going to do is our 2D contour. Sorry, not trace. I am going to go back to my 1/2 inch Haas end mill, because the thicker the end mill is, the more rigid it is, the better finish cut I can get, and just the more general stability. So I'm going to start by selecting this line. Make sure my red arrow is on the correct side. This line. So what this is going to do is cut through those corners. It will both face this face and this face at the same time. And I am also going to cut along, or actually, I'm going to save those as is first, and just let it go up and down. So now we have this face and this face finished. Now next I'm going to cut this face, and the bottom of the groove. I'm going to do that with a series of contours as well. 2D contour. I'm going to select. It auto selects the last tool, so I know I'm still at my 1/2 inch. Contour selected. I am going to go with chain and then select open chain. This will let me select just specific lines, because sometimes it wants to auto select like this whole line here, which it did. And if I OK that, it's going to give me usually something kind of weird. Yeah, it's adding a line in right here. Actually, I can live with that. All right. Sometimes you have to be kind of finicky, and you might have to do more than one contour just to make it work. So everything looks good. See what that looks like. Yeah, so it's giving me the side cut that I want, but at the end of that side cut, because it is also doing this line, it's not cutting all the way through. So what I'm going to do is adjust that. Edit. Actually, I wonder if I can just... No, won't let me do that. All right, so edit. Go back here. Delete that line. So do contour and silhouette. Actually, cancel. Chain. Open chain. Select that line. OK. Then I'm going to do it again. Chain. Open chain. Select that line. All right. So now I have one line going this way, one line coming back with no tab at the end. Sometimes you'll spend a lot of time going back and forth getting these paths exactly how you want it to, because while the computer will do exactly what you tell it to, it's not going to think for you, so sometimes it can be a bit finicky. All right. So for height, obviously it's wanting to start at this line height, but we want to go all the way down. So again, we're going to, instead of going bottom height selected contours, do a selection, select that face. That's dropping our line all the way down rather than keeping it up there. Hit OK. It's exactly what we want to see. The line coming in. Finishing those. Looks good. So now we still have material left here on these outer faces. We can do that by, again, selecting contour. Same 1/2 inch end mill. And we are going to do a silhouette. Outer loops like we did on the last one. OK. Drop to our heights tab, and instead of selected contours, we are going to do selection. So select this face and drop down 0.2. Reason I'm doing that is because I know that the original material is about a 1/16 below this height right here, maybe less. So by dropping down 200 thousandths, I'll have a little bit of overlap, but I won't go far enough down that I'm just recutting air. And passes, so I'm going to do this all in one pass. I don't have to worry about any of that. Hit OK. There's our one pass around our block, getting all that cleaned up. All that's left now is to face the material here and here. Obviously, I could use a flat again, like I did in the last setup. This one I could also use a face. So it's brought up my 1/2 inch end mill again, and I can select the two faces I want to cut. For this, I am also going to go into the passes tab. Pass extension, so this is how far out it's going to extend. I like to extend out a little bit farther than the computer auto does, which is only a 1/2 of a thousandth. I'd like to at least have my extension to be 5 thousandths. As for step over, the step over I'm going to reduce to 200 thousandths. And directions I want to stay as a climb mill. And so the last thing I also want to do is a stock offset, because if I don't, it'll stay exactly within these two lines and I could end up with kind of a burr edge on it. So for the stock offset, I am going to put 0.1, and that will be good. Hit OK. And there we go. We faced our part. So this should be everything we need to do to get this all finished on this end. As just a final check, we're going to do a simulation of the entire block for this setup. Watch it, make sure it's not going to throw up any error messages or run into anything. Yeah, so far it looks pretty good. All right, that looks good. No problems, no errors. Visually, it looks okay. So I'm going to exit simulation, and I am done with this setup. All right, so there is one more thing left to do, and that is to poke a hole. So that is all that's left. This is going to be quick and easy because all of this has now been finished. All that I'm missing is one hole. So again, back to setup, select setup. It's going to give me my stock box. So I'm going to again change to in the orientation to a ZX plane. I'm going to grab it this way in my vise. So my Z-axis will be this face, and the X-axis is already pointing the direction I want, so I don't even have to select it if I don't want to, but I will anyway. And I will also go to a model box point because I don't even have stock to measure off of anymore. So center of the model box looks good. Again, it already went from previous machining, but I am going to click continue rest machining to make sure that I'm not cutting air. Hit OK. So that's showing me what my model looks like in the orientation I need. Again, Y is pointing towards the back of the machine, X is pointing to the right of our machine, and Z is pointing up towards our spindle. So now I just need to drill a hole. So I'm going to go into the drilling tab, and I'm just going to hit drill. It's going to drop up pop up with the end mill that I have been using because it auto defaults to the last tool. I do not want to use an end mill to drill with, especially a 5 flute. So what I'm going to do is select. Now I need to find a drill bit. Obviously, I don't have one in my library right now. So I am going to look through, and I can try to pull one from one of these tools, but tell the truth, I've never used drill bit vendor tools, so I have no idea if they even have the cutting data that I need. I've always programmed in my own drill bits. So I'm going to go back to my library, hit the plus button, go towards my drill bits, which is going to start with a center drill, because that is the first thing I want to start off with. So the center drill, 2 flute, high-speed steel, 1/4 inch. The one I'm using, actually, all these parameters seem correct except for 90 degrees, because it is a 60-degree taper on the ones I have in my shop. So everything, we'll call that good, because I don't have a center drill sitting here on my desk that I can measure up, but normally I would measure, go through all the drop downs. I'm just going to accept it as it is, go to the post processor, and make sure my cutting data is not super crazy. So I'm going to go down to 250 for my RPM, or for my surface speed, and then for feed per tooth I'm going to go down to 0015. So this is a nice slow peck in order to establish our center. Hit accept. Oh, well, would you look at that? I'd already programmed. Oh, no. Anyway, select. So there's our center drill hovering in the air. Here's all our data that it imported. I'm going to go to the geometry. It's going to say select hole faces. So I'm going to select the face of that hole. Now in the next tab, it's showing that it's going to take that center drill and try to drill all the way to the bottom of the hole. I do not want that. In fact, in this, so for bottom height, I'm going to go to hole top. Obviously, it's not drilling anything because it can't drill from hole top to hole top, but I am going to do drill tip through. So what that's going to do is just go to the tip of the taper, which is perfect for our center drill. So that's where we're going to end right there. The cycle will be drilling rapid out. I'm going to hit OK for that. And it will just peck drill that right quick, just to establish our starting point. Now for the hole itself, we need to know what size we're drilling. So over here on inspect, I can click the inspect tool. It's going to automatically come up with this. And secondary units, millimeters, just because I like to see both units. And I can click the face of that hole. My diameter is 0.299. So I need a 0.299 drill bit. I can now look at a drill chart. So what I'm going to do is pull up a drill chart on Microsoft Bing, so we'll even see if I get what I want. Alright, so this is a drill chart. So I'm looking for a 299 drill bit, if that exists. So right here I have a 19/64, which is 2969, or an N, which is 302 thousandths. So this 19/64 is close enough for a tap drill that is what I'm going to choose to go with. So I will be going with a 19/64. So I am going to, again, drill, select my home library. I don't have one already loaded in, so new tool, going to go to drill, Drill 2 flutes, high-speed steel, and diameter will be 19 divided by 64. So it's going to auto-populate. Again, if I had the tool in front of me, I would measure it, but I can also kind of just give a general estimation. So if your length below holder is shorter than your shoulder length, it does yell at you, so just be aware of that. That's what the general size and shape of a drill bit is, so that's what I'm going with for this example. And then I'm going to continue to page over till I get to cutting data. Spindle speed, so surface speed. Drill bits tend to go a lot slower if you're using a high-speed steel bit, because it is high-speed steel, not carbide. So, I'm going to go a 100 SFM. So this will be a 100 is a good just general for drilling into steel if you're not sure what to go for. And then use feed per revolution, and then 0.003 thousandths per revolution. Make sure you click the feed per revolution and not let it just stay on plunge feed rate, because I have made that mistake before and accidentally programmed in a drill bit at 1000 RPM and had it at 60 thousandths per tooth feed rate for feed per revolution, and it did not survive. So I'm going to accept. There's my 19/64 bit. Select that. And next tab over in geometry, select the hole. Next tab over in heights. So this one is going towards hole bottom, but I need to drill through. So I'm going to drill tip through bottom and then breakthrough depth. How far past it am I drilling through? I want to go at least a 32nd of an inch. So 32 thousandths, just enough that I don't leave a burr on the edge and it breaks through. And for drilling, I want to, instead of using drill wrap it out, I am going to do a chip breaking partial retract. This auto loads your pecking depth for you, which is very convenient. And this is based on the diameter of your drill bit, so it will update if you go to a larger or smaller diameter. Gonna hit OK. And that is our drill cycle. So I can now simulate that. And that was way too fast, so I am going to slow this down with the slider. Go back to the beginning, regenerate the stock. And now I can see a drill more reasonably. All right, that looks good. One last thing I am going to do in this setup is actually chamfer this as well, because since I am going to be tapping this, I do want a nice chamfer to start my tap. So in the 2D drop down, there is 2D chamfer. I'm going to select 2D chamfer, and in tools, Haas tooling library, I'm going to go with engraved chamfer, and there's nothing there, which is annoying. So I'm going to make my own tool again. My library plus, and right here, engraved chamfer, cutter. What I am using currently is a 0.25 diameter Haas bit. So it is a 45, 90 degree inclusive angle. The flute length is 0.25. Shoulder length is, shaft diameter, that didn't update. So let's see, 0.25. Tip diameter, overall length. Length below holder is 0.75. Shoulder length, 0.625. That is the tool that I have been using. It is carbide though. To flute. So now I can go to the cutting data, and it will run at 300 surface speed, 4,500 RPM. Feed per tooth, I want to bring this down to 2 thousandths per tooth. And that all looks good. So I'm going to accept. select, and now go to geometry, select just the edge of that hole. Again, it's going to give me an arrow to show which side it's cutting on, which is good. And then here in the passes tab, this is where you decide how wide your chamfer is going to be. So I want to have at least a 32nd of chamfer because this is going to be an Acme thread going in there, so that'll give me a good start. Hit OK, and it's going to show me the chamfer it's putting on there. So the gray material is the model itself showing under the stock, but that's okay because I did not program the chamfer into the model itself, but I know it's going to be there, and that's showing me that difference. So with that, which is our last cut, we can close down that tree and select all three setups and hit simulate. This now will show us the entire cutting process. So from setup 1, where we're going to machine the top of this vise, then it switches to setup 2, where it's going to machine the bottom, and then once that's done, setup 3. Setup 3 goes very fast. It was already done by the time I could get over there. But now we can see we have a nice rainbow colored vise from all the different cuts it did, and it all looks good. As for threading this hole, I will do that manually with a hand tap, so I don't need to program that in. And that is it. We can bring our statistics tab over, take a look at it. Machine time, so run time is going to be just over 15 minutes. That does not include setup times, which is going to add a lot more because setting up your vise and getting everything indicated in is probably one of the most tedious and time-consuming aspects of machining. But as far as getting the CNC programming done, that is everything. We now have our setups. The last thing we are going to do is I want to show you how we would post this code. So to post the code, we're going to select our setup. So setup 1 is going to be our first setup. Oh, before I do that, there's one very important thing that I almost forgot, is our tool library. So here in our tool library, we're going to click tool library now that everything is done. Vise Base 2, this is the library of tools we're using. You can see that 1/2-inch end mill that I had originally posted earlier is still in there. We don't want that. So we're going to select this tab, everything's going to highlight, and then the little broom will remove the unused tools. So now that tool is gone. Also, the number order of this, 2, 3, 4, or 2, 3, 5, 6, 7, 8, we can click this button here, renumber tools. Starting from 1, increment increases by 1. This will renumber our tools in the order they are used, from 1 to 6 now. That way, when we program in, sometimes we're pulling tools from other categories, and you'll have tool 1, 3, 5, 87 even, and this will bring them into a nice even order, so when you're setting in the machine, you're not having to call up weird numbers. Alright, so once we've got all of that done and done and the numbers set up, we can close this tab, and we've seen here everything has updated. 1, 2, 3, 4, 5, 6 in our tool tabs, T2, T1, T4. Now we can start posting. So we're going to click Setup 1 over here, Post Process, or it'll be in the drop down. We can also right click and Post Process. But I'm going to click this button, and then it's going to bring up this page, and it's going to ask us where our output folder is, where all our information is. So first thing we need to do is select what kind of machine we are using. So we can choose from library. Here we can go through all of the Fusion library machines that they have stored. Every different type of machine runs it seems like its own proprietary version of G-code, and this Fusion 360 has a bunch of them in there. So you would go down, you can sort here by milling, turning, jet, all that stuff. Or local, I have the Haas automation pre-next gen console already loaded in because that's what I tend to use most as one of my primary machines. Now, file number. Haas, depending on your machine, I know the Haas ones for milling always take a 5-digit code. So if you have coding system in your shop, you can go with that, or just type in random numbers or find your own number system. And then file name, top of vise body. So this will be all of the machining in setup 1. We have to repost each code for setup 1, 2, and 3 because each time it's going to be referencing a different G54 or origin point. So once I've got that, I'm going to do my output folder, which is just going to be my desktop. And in configurations, I don't have a transport, so I want to make sure that's turned off. Option start, preload tool, I want that turned on. And other formats you can look through. So now I'm going to hit post. It is going to post my G-code for me. All right. Here is my G-code. So this is for our first setup. The only thing we're using is tool number 1. See, it's T1, diameter is a 1/2 inch. Z minimum, this is a very useful bit of information. This is how far down from the top of my G54 offset I am going to be going. And if you're used to reading G-code, this should all look pretty familiar. You can page down. Most of this right now is all the information for the adaptive cutting. You will see when the program changes, it'll say right here, 2D contour, flat 1. But this is all pretty standard and looks good. So I can close that down. Now I would be able to load that, either send it digitally to my machine or load it onto a thumb drive or load it onto my machine and run this code now after I install my tools. I hope to make videos later of me actually loading this onto the machine and cutting it in the machine. But that's all I have for today, or at least for this video. If you have any questions, feel free to hit me up either in the comments or for my students in person.